Okay, now this question here is a word problem. So the first problem that we're going to have is just trying to read through it, decipher all the information that's here, and try to figure out what the question is actually asking us. Okay, so it starts off with Ian throws a ball up in the air and lets it fall to the ground. Okay, so I've got this guy Ian here. He takes a ball. Okay, he throws it up into the air, and the ball comes back down. Right? To the ground, noting. Okay, so he doesn't catch the ball. It starts up, maybe a little bit higher. He throws it up, comes back down. Okay. Now, the height of the ball, h of t, right? That's a function, is modeled by the equation. H of t is equal to negative 16t squared plus 6t plus 3. So right away, we should be saying, I notice that t squared. I know that this here is, in fact, a quadratic function. Okay. Now, h of t measured in feet and time t is measured in seconds. The number 3 in h of t represents. Okay. So this question really isn't asking me to do anything with this equation here. I'm not solving it. I'm not evaluating it. They're asking us one simple question is what does this 3 represent in the function itself here? Now, I go back and I think, okay, what do I know about quadratic functions? There's three types of ways that I could write that quadratic function. I've got standard form, factored form, and vertex form. This here, if you've been paying attention, I should recognize right away as something that's written in standard form. Now, standard form, if you recall, gives us one specific piece of information very easily, and that is the y-intercept of our quadratic function. And where do we find that y-intercept? We find it as the constant term in the quadratic equation. Now, if it's written in correct standard form, that's simply going to be the last number that does not have a variable, which is 3. Okay, so I know just based on the definition that that 3 is going to be the y-intercept of my quadratic function. But what I want to think about is how does that translate over into the context of the situation? So is that the maximum height of the ball? Does that make sense? Okay. Y-intercept, again, if that's like our starting value. Okay. Is that ball starting out at its maximum height? No. He throws the ball up, comes back down. Okay. Not the maximum height. The height from which the ball is thrown. Okay. This here is actually our answer. Okay. And sometimes it's not clear in terms of the language that they use, but when they say the height from which the ball is thrown, okay, remember, Ian starts by throwing the ball. Okay. So this here is actually the start. Okay. He's throwing it. That means that's the start. That, by definition, is our y-intercept. Okay. So the answer for this specific question here is number 2. Now, a lot of times with quadratic functions, you can graph them, you can look at the graph, you can look at the tables to try to analyze that. For this specific question here, even if you look at the graph, even if you look at the table, it might be hard to try and identify where that 3 does show up, okay? But just to kind of give you a visual of that, I'll show you what I could do is that function again was negative 16t squared plus 6t plus 3. So if I add this into my calculator here, negative 16x squared instead of t plus 6x plus 3. Take a look at my graph. I see this here, okay? Not really super helpful, okay? But a lot of times with quadratics is if I go to zoom fit is what you want to look at to get an idea of what you're seeing, okay? Even in this case here, it's hard to tell what I'm looking at. That is even less helpful, okay? So there are some tricks that you can use, but you really have to know what you're doing. I know that I don't care about x values of 0 or more, okay? My y minimum, I definitely don't care about it being all the way up there. My y max, I'm going to set this guy here, maybe let's say 5, okay? So I can adjust this more and more to get a better idea of what's happening in this scenario. Okay. But I'm able to do that because I've got some practice with it. Okay. Now, what I see here is this is a start. My ball is going up. The ball comes down and hits the ground. Now, all that happens relatively quickly because this first tick mark here is at 1 second. Okay. This over here, if I count, I can see 1, 2, 3. That 3 happens here. Okay. That's the starting value that we saw from here. Okay. But again, this is the type of question that's a lot easier if you just have a good understanding of standard form.